Okay, so welcome back to a video on synthetic division notes, and in this video we're going to be looking at example 3, which is to factor the given polynomial completely using synthetic division. So if my polynomial has a coefficient on the highest exponent term of 1, then I'm going to start with a 1 listing out my coefficients. Then we have a -9 is the coefficient on the x cubed, so we'll list -9 next, followed by a +23 as the coefficient on the squared term, -3 is the coefficient on the linear term, and then the constant at the end is -36. And there were no missing place values, so I didn't need to use any zeros to hold missing places. Okay, the divisor, it says we have factors of x plus 1 and then x minus 3 with multiplicity 2. So I'm going to go ahead and start with this factor of x plus 1. To get the divisor, I'm going to use the 0 that corresponds to that factor. So -1 would be my divisor, and then I'm going to go ahead and draw that line for my synthetic division. So we always start by bringing down that first term, and then we multiply and add, going the whole way across. So 1 times -1 multiplies to be -1, and then I'm going to add those two values together. So -9 plus -1 is a -10, and then I repeat. So I'm going to multiply -10 times -1 is +10. Then I'll add those together. 23 plus 10 is 33. Okay, then I'm going to multiply. 33 times -1 is a -33. Then I'm going to add those together. -3 plus -33 is -36. Then I'm going to multiply. -36 times -1 is a +36. And then I'll add those together. -36 plus 36 is 0. And that 0, remember, is the remainder, right? The last term when I get to the end of my synthetic division represents the remainder. Okay, then this would be a constant, linear, quadratic, and cubic term. So if I just were to stop here with the factor of x plus 1, then I would be left with 1x to the third power minus 10x squared plus 33x minus 36. But the problem goes on to tell me that x minus 3 is also a factor, so I'm going to use a divisor in my next division of 3. And when I set up my synthetic division, I'm going to disregard this remainder, right, because that's not going to be part of my new dividend. So I bring down the first term, which is a 1, and then I'm going to multiply. 1 times 3 is 3, and add those together. -10 plus 3 is -7. Then I multiply. -7 times 3 is -21. And then I add those together. 33 minus 21 is 12. Then I multiply. 12 times 3 is 36. And I add those together. -36 plus 36 is 0. And there I have another remainder, right, for my second division is a remainder of 0. So I know that that x minus 3 was a factor. Now it says that the x minus 3 factor has multiplicity of 2. So that means that I can repeat this divisor, and I'm going to divide again into this quotient now using +3 a second time because of that multiplicity of 2. So I bring down my first term. That's a 1. I multiply. 1 times 3 is 3. Then I'm going to add. -7 plus 3 is -4. Then I multiply. -4 times 3 is -12. Then I add. 12 plus -12 is 0. And that 0, again, is the remainder. Okay, and now I have used all of the given information So I'm going to go ahead and interpret my final quotient here. So if 0 is the remainder, next comes the constant and then the linear term. So this is going to end with a quotient of x minus 4. Right? This original divisor of -1, that came from the factor of x plus 1. And then this divisor of 3, that came from the factor of x minus 3. Right, this divisor of 3 also came from a factor of x minus 3 because it had multiplicity 2. And then my quotient is my final factor, x minus 4. So the completely factored form is an x plus 1, then an x minus 3 that has multiplicity of 2, and then my quotient is a factor of x minus 4. Okay, so that would be the factored form, which will allow me to sketch this graph by putting real zeros at -1, at +3, and at +4. Then I can analyze my end behavior. So I see in my original polynomial, this is a positive leading coefficient and an even degree. So positive leading coefficient and even degree tells me that both ends are going to face up to positive infinity. Okay, I have a cross at the -1. Since this end has to go up to positive infinity on the left, I'm going to be decreasing as I cross through -1. Okay, then the even multiplicity on my factor of x minus 3 means when I turn here to approach the x-intercept at 3, I'm going to have to bounce at that intercept. And then I have a linear factor of x minus 4. That's another cross. So I turn and cross through the 4, and that would be the graph that accompanies this original polynomial x⁴ minus 9x cubed plus 23x squared minus 3x minus 36. And that brings us to the secret question for this lesson, where you're going to factor the polynomial f of x equals -2x cubed minus 7x squared plus 7x plus 12 using synthetic division, and the factors x plus 4 and x plus 1. Okay, so you're going to factor showing your work for the synthetic division. Okay, you're not going to get credit if you don't show the work. So do not just write the factored form. You have to factor it using synthetic division. Then you're going to find all the zeros and sketch the graph using bounce, wiggle, and cross. Okay, when you have completed the secret question, you're going to upload that as the last page of notes when you upload your notes to Schoology.